Now, the good news is problem solving has happened all throughout this module, from learning terminology to the 3 different approaches that we used to the intervention that was a hands-on approach potentially with your students. So, but let's get more specific about word problem solving. Research is starting to emerge on solving equations using model-based problems or word problem structures. Model-based problem solving is starting to see research, and I can't wait to share that once we see more replication studies come there. But until those replication studies come, let's do with what we know we see data with, and that is using an attack strategy. The attack strategy we're going to use today is solve. Study and read or paraphrase the word problem, right? Organize the facts and visuals by underlining key ideas and not regarding what is not a key. Then line up a plan, verify that plan, and examine and check your answer. So let's get through a problem with Jared. Jared, I think, is a stinker and he's finding a reason to buy more playing cards, but that's not okay. That's okay. Maybe he's just a sweet kid who loves his sister. Here we go. Jared gives his sister 1/2 of his trading cards. He's a giver. He then buys 10 more cards. If he has 19 cards now, how many did he have initially before he gave half to his sister? So we want to represent that situation mathematically, and then let's determine how many cards Jared did have initially. So let's get through this. Through solve, we need to study it first and paraphrase. What are we doing here? Well, we're determining the number of cards he had is unknown. Yes, the number of cards he originally had is unknown. He gave away half those original cards. He then bought more. I got a sequence going on here, this, then this, and now he has 19 cards. Okay, so we've got a sequence and we've got our unknown. It's a great start. So let's set up the equation for this. It means that he has 1/2 of x. If x represents the number of cards he had initially, 1/2 of x, then he bought 10 cards and he now has 19. Makes sense. So let's line up the plan. I'm going to solve for x and see if that number makes sense. My plan is going to involve an additive inverse and a multiplicative inverse. Okay, so let's go through it. We had an additive inverse, then a multiplicative inverse. And what did we get? He originally had 18 cards. Okay, he had 18 cards. Let's see if that makes sense and examine it. Put it back in. 1/2 of 18 is 9 plus 10, 19. Good. So Jared originally had 18 cards. He gave away 9, leaving him with 9 total. He then bought 10 new cards. Now he's got 19. That just seems to make sense. In other words, we can use SOLVE to have students walk through and make sense of a word problem and get to the answer. The idea is so that you don't just go ahead and go, solve this. It's teach students using solve and then tell them to go through the process and even check their process SOLVE, either in pairs, triads, or with you. Your turn. Try using solve for this one. The Cat Cafe sold 36 drinks last hour. Okay, they sold twice as many coffees as they did sodas. Set up an equation that shows the number of drinks and then how many coffees and how many sodas did they sell. Okay, bonus. If they still only sold 36 drinks total, but they sold twice as many coffees as sodas, what if they also sold 6 milkshakes? Set up that problem and solve it. All right, the idea here is not so you need to practice your math. You're good. The idea is here, practice how do you solve to getting through this problem solving, this word problem solving equation and making sense of this word problem. Again, we want to help our students get through the word problem solving process.